So good morning learners and welcome to today's science lesson, the 20th of August. Now we're going to continue with the remaining three sources of current electricity. That is, I told you about generators, the geothermal generators, the wind-driven turbines, and the solar energy panels. Now I will explain something about the geothermal. Geo, the word geo means earth, and then we have thermal, which means heat. Now, geothermal, so this is exactly heat that comes from underground that is used to run turbines. So a geothermal generator is a large generator that produces large amounts of electricity. Geo means earth and thermal means heat. Therefore, they use these generators use heat from the earth, to produce electricity. So the heat, when you talk about heat, learner, talk about steam. You can't get heat without steam. So the steam comes, assuming this there is steam coming from here. So you know steam is in vapor form, evaporation. When you heat something beyond liquid, okay, it becomes gas, you continue heating, what happens is it produces vapor. Now the heat coming from this underground will be tapped. This one is tapped, controlled how it will come, and then maybe allowed to come through a very thin hole, so that it can be controlled, directed where the machine is, which can be able to get that and take the machines that can be able to produce electricity. So the steam is at high pressure. The steam comes from the earth, a lot of pressure. So this is very, very important, that it must come with a lot of pressure to be able to produce electricity. Produce electricity. It's not a common thing, but where we have the craters, we are likely to experience this because of the amount of action that takes place under the mountains. So when it tries to come out, it must come out with a lot of pressure. Some of the electricity we use at home is derived from geothermal power stations in Rift Valley. So this one happens in Rift Valley, where we have a lot of actions of the mountain. The next one is going to be wind-driven turbines. That is H, the wind-driven turbines. Now you must have seen this even along our way here to town, where we are just after Bamburi. You will see something like this. You must have seen something like this that rotates. So it's made like this. You must have seen it rotating. So these are what we call the wind-driven turbines. Wind-driven turbines. So wind will come and hit on this turbine. So this turbine will keep on rotating in that direction. And so you realize that there are some wires that are connected to this one. As it rotates, it produces electricity. And this happens mostly in the Turkana parts. We have Turkana, Marsabit. Those areas which experience a lot of wind, they can be able to use that wind to be able to produce electricity. Right now they are saying there's a lot of wind there, and they need to utilize that to be able to produce electricity that can supplement what we get here in our country. So wind is a good source of electricity if utilized by having those turbines erected. So whenever there is wind, they are going to rotate these turbines to be able to produce electricity. So these are generators which can produce large amounts of electricity. A fan driven by the wind to rotate the generator that produces electricity. So that is all about the wind-driven generators. So wind rotates the fan to be able to produce electricity. So once they rotate, they are connected to a machine which taps that and produces electricity. Last but not least, this learner, we have the solar panels. The solar energy panels. I know you know this, learner. The solar energy panels are used basically to produce electricity. I'm sure you have seen things like this put on buildings, on top of buildings. Some slates like this. These are what we call the solar panels. Now these solar panels have cells. How they produce electricity? They have cells that when light shines on them, they are able to convert this light into electricity. So it is not heat, learner. There is something we confuse, that solars do not use heat to produce electricity. They only need light. Whenever there is light, that is enough, because these solar cells, there are cells there. They can be able to sense. Whenever there is light, they will sense and convert that light into electricity. So there is conversion of light energy into electricity, into electrical energy by the solar panel cells. Like we talked about dry cells. So this solar panel has cells that are applied on top of on the upper part of the solar. So solar panel produce electricity when the sunlight falls on them. Solar means sun. Therefore, a solar panel is a light-sensitive cell that converts light energy from sun to electricity, like just what I've said. So once the light falls on it, you can be able to sense it very fast. Convert that light energy into electrical energy, and that will be supplied using cables into your battery, where you can store it and later use it for any other purpose that you want. Maybe to power on the TV. You can also use it to iron when you connect into a socket where we have the iron box, and you can be able to use it to do that. So now I want to say the last thing about this, what you have just done. And this last thing is sources of energy that produce sources of energy, not energy in this case, electricity, that produce electricity by rotating. This is a question in even KCPE, so I want to just mention it because learners sometimes get it wrong, and it's a very simple question. The ones that we have mentioned that produce electricity by rotating. Number one, we will begin by what we call the ATP, the hydroelectric power, which is generated by hydroelectric generators. Hydroelectric generators. They must be able to rotate to be able to produce power and they produce current electricity. Number two, we have what we call the wind-driven turbines. Wind-driven turbines. They produce electricity through rotation. They must rotate the fans to be able to rotate to produce electricity. Number three, because we have petrol and diesel generators. They must rotate, I said. So that's why the reason we add to them fuel that can be able to power them and rotate to produce electricity. Number four, we have the bicycle dynamo. A bicycle dynamo must rotate for it to be able to produce electricity. Then we have, of course, the geothermal generators. Geothermal generators. We also have, we mentioned about hydroelectric generators. So these learners, these are very important, very important to take note. In an exam, they will ask you, which of the following does not produce electricity the same as a bicycle dynamo? So what comes in your mind when they say that? How does bicycle dynamo produce electricity? By rotating. Simple as that. So if you remember that, you will be able to look at the other ones, and maybe you will see in the answers solar panels. Solar panels do not rotate. I've just said they just sense the light. They have cells which are very sensitive. So once there's light from the sun, they're able to sense and capture that, convert it from light energy into electrical energy. So this is very, very important as far as this unit is concerned. There are very few questions that come from here, and the ones that come from here, they are very, very confusing questions. So you must get it right for you to be able to understand the whole thing. So in our next lesson, learner, we are going to talk about the simple electric circuits. So we are going to understand what a circuit is in our next lesson. The one that I gave you, the one that produces electricity by use of dry cells, is a good example of a circuit, but now we're using dry cells. So whenever we are not using dry cells, what are we using? So a circuit must involve so many things. There must be a bulb, there must be the source of power, maybe a generator, maybe a battery, maybe a dry cell. There must be the connectors, which are the wires. So all these things we are going to see how they are arranged for them to become a circuit where electricity can be able to flow from one end. So I want to wish you well. Ensure that you make some simple short notes on what we have just done, and ensure that you are reading. Every time you are reading, you go look for questions from these units, try to answer them, and I know you're going to get them corrected. Until next time, learner, I want to wish you well. Have a blessed day ahead. Continue doing a lot of good work. By the end of this week, that is on Saturday, I'm going to give you a science paper so that you can see what we've been doing and how it is applied in an exam. God bless you.